5.5 that was created as some syntactic sugar around iterators, and we have allowed it to be useful to us in doing cooperative multitasking. Just 100 lines of code. This could get far more intense if we started to do things like exit signals of tasks, or actually using the send method or the throw method. But for now, this serves as an interesting example of how we can use this for multitasking. It's perhaps not in its most useful form. I expect many of you are thinking, well, how do I use this in my code? How do I make something useful out of this? It's interesting to know, but what do we do with this? Oh, first I have to show a picture because it's in my slides. I know, right? So simple. There's a project on GitHub that you can go to called Icicle. I spoke a bit about this yesterday, but I didn't go into the specifics of how generators are applied here. An Icicle is interesting because it gives you functionality that you would expect to be in core PHP, but it gives it to you in a way that you can create asynchronous architecture to do simple things like reading and writing to files in a non-blocking way, or resolving domain names through a DNS server. Here's an example of setting up an HTTP server. We get a request and the socket that that request is sent inside this function. And because we can see instances of the yield keyword, we know that this function creates a generator. But if you hadn't noticed that, you would have thought maybe that this code looks very normal, very synchronous, very traditional. It's not though. It's doing asynchronous stuff. If the body of this request is readable, it fetches a bit of that body at a time. This is a promise, and I'll talk about promises shortly, but this read method returns a promise. And that promise is to say, this body is a stream of data. So fetch a little bit of data, and after you fetch that data, resolve the promise. This will read from the body stream incrementally until everything is read from the stream. It will store it in a temporary memory stream as well. In this case, it's called a memory sink. It's basically just a wrapper around a stream of data to be able to do things like rewinding and serialization. So here, the function execution suspends until that stream can be read from. Here, the function suspends execution until that memory sink or that stream decorator is complete. And here, the function suspends until that response is generated and able to be rendered to the browser. These are 3 points where code that looks very synchronous is actually doing something asynchronous. It's giving up processing power back to the server, back to the PHP interpreter that's running this, so that it can do things like serve other requests in the time that it's waiting for these potentially blocking or potentially time-consuming tasks to be done. It's trying to do that in an asynchronous, non-blocking way. Because it's a server and we manage socket connections, we just need to listen on a certain port for incoming connections and run the event loop. And this event loop in Icicle is built around the concept of using coroutines, the functionality that I've demonstrated from generators, and promises. And we'll look at both of those things. But first, here's another example. This is an example of using Icicle code and generator functions as coroutines to spawn child processes to be able to do work in a separate process. This fork spawn says, take this function and run it in a separate process. This is concurrent programming that looks like just normal synchronous code. It's simple to read once you understand what the yield keyword is doing, and yet it's doing stuff quite complex. It's making a whole asynchronous architecture work for you. We can do something in the main thread to say, okay, each second print something out. So when you run this function, what you're going to see is dot, data, some data, dot, data 42. When you run this, I'm not going to run it right now. Just take my word for it. So this lets us do concurrent programming. It does it because it's using generators to make coroutines. Now, I mentioned promises, and promises are a concept that I think, the first time I heard of them were when I was looking at JavaScript stuff. This is a concept that's very familiar to JavaScript developers, and it's a way of avoiding a problem called callback hell. If you've done a lot of JavaScript, you've undoubtedly run into instances where you have operations that depend on the completion of each other. You could, for instance, have an interface where you click a button and that's supposed to load some data from an AJAX request. You wait for the event to happen, you make the request. You wait for the event for that request to complete and come back with data. You wait for that data to be passed, and then you wait for an element to be updated from that data. For example, how that will look in JavaScript is you'll have 5 or 6 callbacks. It'll just be like a giant Hadouken of code. Promises are a way of stitching those callbacks together so that we have a less deep structure in our code. We can wrap callbacks in a promise in such a way that we say, when I call this function, if it returns a promise, what it's saying is not, here's a value. It's saying, here is something that will eventually be a value or an exception. And when that happens, you can call a then method on it. You can give callbacks at that point. Or you can start to chain stuff. You can have a promise with a then method that returns a promise. And that outside structure has a then method which returns a promise. And you can have quite a long chain of operations that have to happen with just 2 levels of nested callbacks. It's an organizational pattern, but it's still callbacks behind the scenes. Icicle uses promises for the smallest indivisible unit of work. Most of the functions that you call in the Icicle code return promises, which means they return not a value, but an eventual value. Something that would otherwise take an amount of time to wait to resolve. A request to a server, a request to a database, writing to a file, that kind of stuff is what would be resolved at the end of a promise. And Icicle uses this as the smallest unit of work. It stitches promises together inside generator functions and wraps those generator functions in things called coroutines, exposing all the functionality I showed you generators have earlier in a nice API. So where promises are the smallest unit of work, coroutines are combinations of promise stuff. They're for larger things, like when you're resolving a DNS, when you're resolving a domain name through a DNS server, you have to do lots of waiting operations there. You have to open a socket connection to the server, you have to send data, you have to wait for a response. Many things in that process would otherwise be waiting, so they resolve to promises, and coroutines are ways of stitching those together. Here's another example I'm not even going to talk about. Here is how it does that checking in the coroutine class. It says if what I get in a single unit of work from a generator is a generator, wrap it in a coroutine. So, when you have a coroutine, whatever it yields, you can assume is a coroutine. If it's a promise, if what you get from the yield keyword is a promise, then when that promise is done, do this extra stuff. And if it's not a generator or a promise, use this value in the next iteration of this generator. It's basically a way of containing what could be normal PHP values, what could be promises, what could be other generators, in a consistent way so that when you yield something in Icicle code, you could yield a returned promise from a call function, and it will just work. Another thing I want to talk about is recoil. So, yesterday I spoke about a project called React. It's like a series of libraries to do asynchronous programming. It doesn't use generators at all. It has an event loop, just like Icicle, but that's not based on coroutines. It has a promise implementation, and a lot of the my thing just buzzed. A lot of the function calls in React PHP will return promises as well. But what recoil does is it focuses on this idea of using coroutines. It's not as extensive as the kind of functionality you find in Icicle. You can't read or write files if you use recoil. It's not a drop-in replacement for that. What recoil does, which I find interesting, is that it provides an alternative event loop for React. You can use a React architecture, you can have a big application based on React, and if you're interested in using coroutines to make that work, you can use the event loop from recoil. That's a drop-in replacement for React's event loop to do what Icicle is doing on its own. And I think that's pretty interesting. It does code like this. So this resolver factory is a DNS resolver. That's the example I've been using all the way through. From React to say, okay, connect to this and then resolve these domain names. But instead of using the React event loop, you can use the recoil event loop. And this recoil run takes a generator function and creates recoil's version of coroutines around that. Now, you may be tempted to think this whole talk is about PHP, and it's not. It's about doing asynchronous code. All my examples reference PHP, and because you are PHP developers by and large, it makes sense that I talk about PHP. But the concept of coroutines and using generators to make them is not limited to this language. Other languages that don't have coroutines but have generators, well, this knowledge is portable to that. We can do this in JavaScript, which is, by the way, the most entertaining pronunciation that I've ever heard, and the only way I'm going to pronounce it from now on. You can do this in JavaScript in exactly the same way. Remember that PHP scheduler code we have? How to use it? Well, this is a JavaScript alternative. If you go to something like babel.js.io, you can download a transpiler which will convert this into ES6 compatible code, or code that can be run in any browser. It'll take this and it'll make it runnable in any browser. You also need to include a polyfill, which Babel.js will do for you to get generators to work, because the syntax so far is not too stable. But this code closely resembles what we were doing in PHP. I used a different loop structure. I printed instead of console log. In JavaScript, you have to do star for it to recognize that this function makes a generator. But you still have yield. You still enqueue tasks. This looks like our code. The scheduler looks the same. We're still pushing an item onto the back, getting it off the front, running it, and if it's not finished, putting it back on. In the task, we're still executing a single iteration of the generator. But with the caveat, JavaScript generators in their current form are slightly different to PHP ones. If you run to the end of a PHP generator, valid will return false. And there's no valid method alternative in the JavaScript generators. Each iteration of a generator in JavaScript will return an object with a value parameter that is the current value of the step, and a done parameter for whether the generator has reached its end. So when you get to the end of a generator in JavaScript, the object that's returned has value null, done true. Until that point, you have value for whatever that step's value is, and done false. We had to change the code slightly to adjust for this. But by and large, the implementation is exactly the same. This knowledge is portable to other languages. That's an interesting thing. That's mathematical, in fact. This is not the kind of talk that you can walk away from and say, I have this part of my application that I can swap out a generator for. It's the kind of talk that's supposed to inspire you to say, well, there is this keyword. And I can use this keyword to do what is not traditionally done in PHP, which is to create asynchronous code. And that there are libraries based on this idea, like Icicle and like Recoil, that have code in them to do those practical application things. Code that will power your everyday applications. Things to write to file systems. Things to make external HTTP requests. Asynchronous stuff in general that is done in Icicle and Recoil, and powered by this idea that you can use generators for multitasking. That's all I have for you. We're over time by 2 minutes, but are there any questions?
Do Icicle react to Recoil support a blend structure like in JS or something like that? So like if you have like 20 problems doing for a specific task, if you use 20 tasks and do something else, they have like a blend or
yes. So the question was, do Icicle and React and these people who have implemented promises have the ability to?
So it's on the end and done.
Yeah. They do. They have functionality to do higher order process stuff. You can group processes. You can do things like you're used to from A++. It can be done. It can be done.
better.